Ed from EHCC on behalf of TEC, and today's topic is using a hot wire anemometer to traverse a duct. What we have on the screen in front of us right now is two examples of hot wire anemometers that you might want to use. Convenient tool to use in its specific application. And that's something we're going to talk about over the course of the next couple of minutes. And in this slide, I'm going to show off some of the older equipment that I personally own. This is a hot wire anemometer that it was the first one I ever used. I worked for a fellow by the name of Pete in the mid to late 80s, and that's Pete's handwriting, because the formula to take your velocity and convert it into CFM is the same as it is today as it was back in, let's call it 1987 or 1988. Drill some holes in the duct. The proper location and the quantity are important. What am I referencing there? I'm referencing figure 1 over here to our right. Figure 1 is an example of what is involved with doing a formal traverse. To ensure that we're going to get the most accurate results that we can, we want to follow a documented procedure, and that's exactly what we have here. It's listing 10 duct diameters upstream from the measurement being straight, and the idea behind that is for the airflow to become more uniform. The process is fairly simple. In fact, I am going to skip going through them individually here and jump to the next slide. And we're going to get out of this slide simply by going over the fact that when we're using a hot wire anemometer, a modern instrument, it's going to give us the ability to put in the area of our duct. And when it knows the area of our duct, it can give us a direct reading of our airflow. In this example right here, we have Steve in the lab at TEC. And he's made holes in the duct in the appropriate locations. He's taking his hot wire anemometer and inserting it in the hole. And over here, we can see a variety of velocities that hot wire is measuring. The more consistent we can be with taking our readings, the more consistent our results are going to be. We're after that predictability and repeatability, and that's what we can achieve by being consistent when we actually take our readings. One of the things I want you to note in this chart right here, we see some numbers that are pretty big. And I think the biggest number we saw over here was 900 and something. And the smallest number I'm picking out, and you might pick out one that's smaller, but I'm saying 408 is the smallest. There's a big discrepancy between those two numbers. And that's a perfect example of why we do a formal traverse. Pros of using a hot wire: it's cost effective. Once you purchase the tool, that's pretty much it. The other stuff that you're going to use in relation to it, stuff you most likely already have. And again, limited equipment is required in order to do it. Cons: the more straight duct we have is going to result in better measurements. We don't always have that, especially in residential applications. Doing a traverse is always going to have the baggage of being time consuming and all that good stuff. And then last but not least, it's not recognized by the agencies that are going to grade our installs. And with that, I'm going to hand things over to Bill Spohn from TruTech Tools. Bill is going to share some quick tips and some options for tools that you might be interested in. Take care, and I'll see you next time.
Well, thank you, Ed, for passing the ball here. We're going to be talking about measuring airflow with hot wire or thermal anemometers. Some of the quick tips I want to give you is to make sure you pick your traverse target locations first so you can concentrate on making a great measurement when you're doing your traverse. So have things marked off with a Sharpie, have your holes drilled in the right locations. You want to take your time, record the readings. Hopefully you got a device, a tool, an instrument that actually records the reading. You can just press a button and snapshot that recording. Hopefully it also can do any calculations you need to do. And you want to use a steady hand and a careful eye as you're doing this. You want to use the straightest section of ductwork you can possibly achieve, as we talked about earlier, and be thorough in your work. Different tool options are available, anywhere from things like smart probes, a Testo 405i, and it actually folds pretty neatly for easy transport. It connects directly to an app for Bluetooth, and the app does the calculations for you inside the app. And by the way, all these prices shown here are list prices for the product, circa January 2021. And you can often get these products for a little bit less money if you shop around for things. TruTech's a good source for them, of course. Fieldpiece STA2 is a great thermal anemometer, very rugged. It's got a marked telescoping probe, just like the Testo does, so you know where you are as you insert it into the ductwork. The Fieldpiece has a dual display to show you CFM, can actually calculate CFM as well as the velocity or the temperature on the display. So you got two different lines on the display. The Testo 425, very sensitive, very precise device. Again, a marked telescoping probe. It calculates velocity as well as the CFM if you put in the cross-sectional area. And then there's the TSI AP800, which is a great, precise, multifunctional thermal anemometer with modular. It's got several different probe types, including extensions. This has a great display on it, but it also connects to an app. It has a data service available, and it also can log on to an SD card. So there's a lot of great choices out there. There's also Testo 400. That's a series of multifunction instruments. TSI also has the 975 series. You really got a lot of great choices out there. Check with your test instrument dealer for the right kind of product that's going to be appropriate for what your application is. I want to thank you for listening to this. I want to thank our partners, Steve Rogers and Bill Graber at the Energy Conservatory, and Ed Janowiak at the Eastern Heating Cooling Council for helping us develop the TEC HVAC Air Flow training sessions here, these videos, putting together the videos, reference guides, and more information to help you all do better work, have more knowledge about the work you're doing, really get more confidence in the work you're doing. It's going to be better for you. You'll feel more comfortable doing the work, better for your employer, and better for the customer. So I want to thank you for listening to this hot wire or thermal anemometer duct traverse overview by TEC. And want to thank Ed for keeping nice and warm his thermal anemometers. Maybe he's got a couple hidden under that coat there. We're not exactly sure, but Ed's a great guy. We appreciate you listening and hope to have you come back again and see a couple more videos in the HVAC Airflow series. Thank you very much.